Hey guys, and welcome to the third part of the uFrame tutorial. I have just updated my uFrame, and apart from some bug fixes, we also got a new decent feature, an ability to use shortcuts in the diagram editor. So now you can save a few mouse clicks when you want to manage items in your diagram. So make sure you learn those, and I will try to use them while I record this tutorial. In this part, we're going to start exploring our abilities in the uFrame. It's very important to know what kind of things are managed for you by the uFrame itself and what do you have to code as a developer. But instead of rushing directly into coding, we're going to look at the classes which are generated for us. Hopefully such a research will help us understand how to utilize uFrame and make our coding as enjoyable as possible. In order to follow this tutorial, you should be familiar with such C# concepts as property, event, generic and partial class, and a bit of lambda expressions and functions. Otherwise you may feel a bit lost. And this part is probably going to be the most difficult, but the most rewarding as well, because you will get basic understanding of what's going on behind the scenes, and this will allow you to code more confidently. Also, you will be able to solve some of the issues which pop up as you develop your own games using your own knowledge, and who knows, maybe you will be able to help others on the forums. We're going to spend most of the time in the Visual Studio, so let me go ahead and get you familiar with those parts of the interface that we will use so you won't get distracted. I'm going to work with the code view split vertically. On the right hand side, I will keep files which are generated by uFrame. These are called designer files, and they will be the main source of information for us. On the left hand side, I will show all the other files which will be useful for the current discussion. And pay attention to what tab is opened right now. You can see the name of the file right here. And one last thing, as we progress, don't concentrate much on the implementation. Instead, think about the concept, about how those align in the MVVM puzzle and, well, yeah, draw a big picture in your head. Let's start with the view models. If you pick up any random view model right here, you will see that its class is actually empty. But don't be confused, it's only a part of the class, and it's prepared by uFrame to store our own stuff here. But the rest is hidden in the designer file. And this is a very convenient way of hiding boilerplate code and keep things clean. This also makes me feel like my project is lightweight and easy to understand. All your designer files are stored in your diagram folder right here, and all your view models are stored in the file named after your diagram name followed by .designer extension. If you open this one, you can see that even though we only have 3 simple view models, we already got a pile of code generated for us. But don't be afraid, this code will be hidden from you most of the time unless you wish to understand how things are structured inside uFrame. And luckily it's our case, since we're going to break this pile into pieces and explore each one of those. So let's start with the platform view model. You can see that it is derived from the view model class. We're not going to explore this one much, but later we will take a look at what kind of functionality it offers for us. And as you can see, we got a few things defined here, like variables, properties, constructors right here, and a few methods. While view model class defines general functionality for the view model, here we only got stuff which is strongly connected with this exact view model, platform view model. We got related commands and properties. And if you look closely, you can see that this is exactly what we need from the view model, commands and properties. Let me create a useless method here just to receive the autocomplete functionality. If you know what is a C# property, then you may consider this generic P class as a property on steroids. It produces events about changes and also stores some useful data, like current value, last value, and the owner of the property. Look at this. You can see that we have a value changed event. We also got the current value, the last value, and the owner, and a few other things like, for example, property name. As you have already guessed, this is what transforms our model into a powerful view model, since it has events about changes, and we can allow different objects like views subscribe to those changes. Coolio, but it has sort of long name and doesn't look that much natural. In your code, you are going to set and read those values a lot. That's why regular C# properties were generated for you, and you can see that they only serve to set a value of the underlying power.property and receive its value. So nothing that much difficult. We also got a few commands here. And yeah, you can subscribe to those and execute those. Look at this. We have execution events and we have an execute method. We also got a sender and a parameter. For the sake of extensibility and encapsulation, regular properties for those command variables were generated. For example, a move property right here. At this point, most of the code here makes sense for us, as it fits nicely into the MVVM puzzle. But let's take a look at the rest of the code. We got a few constructors here. First one is default. It invokes base constructor and initializes viewModel properties for us. But what about commands? Well, P property is something that belongs to the viewModel and doesn't require any external setup. So we can simply initialize it right away, but commands are different because they are bound to the controller, which will handle their execution. That's why they are reinitialized every time you set a controller. If you don't believe me, look at this second constructor. This one invokes the default constructor and then sets up a property. To be more specific, it sets up controller property, which it gets from the parameter right here. Now look at this wire commands method. As you can see, this is where our commands get initialized, but this one is invoked from the viewModel controller property. So every time you set a controller for this viewModel, where commands method is invoked and it initializes our commands based on this particular controller. So pay attention to those, because every time you feel like your command is not being executed, that means that it's not wired to the controller. Now, we got a few other methods here. We got unbind method, which we will talk about later. We also got fill properties, which is used every time in the viewModel when you want to get viewModel properties right here. And the fill commands method exists with the same purpose. Finally, we have two methods that handle serialization and deserialization, read and write. These are basically used when you want to transform your viewModel into a string and send it over the network, or just save and load the game. Now we got a few things left. Look at this parent Pinky Aliens game property and the underlying variable. As you can see on the diagram, platform is simply speaking a child of Pinky Aliens game. So every time you are given a particular platform viewModel, you can refer to this property right here to get the Pinky Aliens game, which has this platform set as its player right here. And finally, we haven't seen collections yet, so let's navigate to the Pinky Aliens game viewModel right here, and we can find model collection here. It's called enemies property. If you try to use this and get some autocomplete stuff, you can see that this also reports changes for us. And this is awesome because things are just consistent. Every time you have something in the viewModel, you can expect it to report changes, except for parent properties, like parent Pinky Aliens game right here. I'm not entirely sure if this could be useful to get those, but it's up to uFrame developers. So now, what seemed to be a scary listing of code now makes complete sense in terms of MVVM puzzle. So now, when you know what's going on in the viewModels part, you don't even have to look at this code anymore. Instead, you can modify your little partial class files and add all kinds of stuff here. You can define variables, methods, indexers, and pretty much everything, but be careful and don't break the MVVM pattern. For example, if you add a monobehavior property here, you will immediately break all the idea of MVVM. And also, don't put any logic here. I encourage you to get a cup of tea and follow me as I make a little summary of the most important things in the viewModel object. When referring to any viewModel, you can find your properties in two different forms. powered up properties, which are very powerful, but you should be careful in the way you use those. And simple properties, which just serve to set and receive underlying values of the powered up properties. You also have your commands here, as well as controller, which are those wired to. Finally, you have methods for serialization and deserialization, such as read and write. Let's take a look at our views now. They're stored in the file named after your diagram name, followed by views word and .designer extension. Let's open this one. Views are a little bit more complicated than view models, but we're not going to explore every single piece in this case. Instead, we will learn the most important things, which will help you to get started, so don't be afraid. As you can see, we have even more view-related classes than actual view models. To explain this, let's think a bit. View model is sort of a standalone, as it doesn't depend on anything else, but the view has to be bound to some view model, otherwise it would have no information to display. This basically implies that we can have more than one view to work with a single view model. So let's go ahead and create a second view for the platform view model. And let's actually use the shortcut. Bingo! Let's call this platform GUI view. Hit save and compile. Actually, I should have used the shortcut. Still have to get used to those. Now, if we reload, and let me collapse all the classes again. As you can see, we got even more classes generated now. And those relate to the platform GUI view. And notice this pattern. We got this view base, which is named after the element name followed by view base. This one is derived from the very base class called view base. And all the views are derived from this one. Then we got a class which is named after a particular view name. In this case, it's platform view, followed by view base. And this one is derived from this platform view base. Finally, we have this little partial class, which is actually empty, and this one is derived from platform view base. As you might have already guessed, this is a class we're actually going to work in. But all the same applies for the platform GUI view right here. We have this little partial class derived from the underlying parent class called platform GUI view base, which again is derived from platform view base right here. Now, if you think this explanation is not sufficient, and in fact it's horrible, then think about it for a second. We have all those views bound to a single platform view model. So they definitely going to have something in common. Like, for example, methods and algorithms which tell them to work with this view model. Or, for example, methods to execute commands, because every view should be able to execute commands. But they also will have something different. For example, bindings and two-way properties, which is the topic for another discussion. So that's why you have this first base class named after the element itself. And here you got those commands execution methods. You also have a few other things which we are going to talk about in a second. Then for each view you have also generated a special class which contains things that are unique for this view. And finally you have a partial class where you can store your own stuff and modify the existing. Let's see what do platform views have in common. To do this, we navigate to the class which is named after the element name followed by view base. This is where all the common stuff is stored. As you can see, we got a few variables as well as properties and methods. Let's break those down and explore it one by one. Those variables right here correspond to your view model properties. And this is exactly what you see when you drop a platform view script in your scene and check initialize view model right here. You expect those to be the values of the view model when you launch your game. So they never contain the runtime values of your view model properties. But you can use them to initialize your view model when you instantiate some object in the, during the runtime. As you can see, all those variables are used in the initialize view model method, which accepts a view model. And this one is called from the view base initialize data method right here. And you can use this one every time you instantiate a prefab in the runtime and you're going to make it a view of some view model. And in this case, you're going to get your view model and you can call initialize data on this one, on this particular view I made. We also got helper methods generated for us to execute every single command on the current view model. For example, execute hit, execute move, and as you can see, this one has a bool argument. This is because our move command is defined so that it carries a boolean parameter. Finally, we got a few properties here which can be handy if you are an advanced user. But we're not going to explore those much right now. The only thing you need to know is on every single view you have a property which name corresponds to the current element. So this one is platform property and it contains the view model which this view is bound to. At this point, we know that every single view can execute commands for the underlying view model. But we still have no idea how view can react to changes in the view model. Of course, we could directly subscribe to the powered up properties on the underlying view model, but in this case, we're going to do the uFrame's job because this is something that could be done in a standard way, you know, something that is boilerplate. So this is time for us to learn bindings. And this is a very important topic, not only for the uFrame, but for the MVVM concept in general. Meet the Jack. Jack is quite unhappy, as you can see. This is because the only two things he has in his life are two pieces of paper, which tell him what to do and when to do. But Jack is quite dumb, and he only recognizes two orders, to work and to relax. When he's told to work, Jack automatically starts to follow all the objects in the world around him and does what he is told when a certain event occurs. But when he's told to relax, Jack automatically throws those pieces of paper away and stays inactive and does nothing. This is a quite simplified, intuitive definition for the binding. Every time you tell the binding to actually bind, binding starts to do its job and does something when a certain event occurs, while unbind means that binding should clear itself and do nothing and stay inactive. uFrame relies on such slaves, so let's see how we can benefit from those. If we navigate to the iBinding interface, we can see that apart from a lot of scary stuff here, it has two methods, bind and unbind, which correspond directly to what I have told about binding. Now let's navigate to some implementation of the binding, for example, model property binding. It implements the bind method just like it's supposed to. As long as it is a model property binding, it relies on a model property value changed event and does something that it's told to. And also it passes current model property value as a parameter. If we look at the unbind method right here, we can see that it does the opposite thing. It unsubscribes from the model property value changed event. So bindings and their different implementations can be used every time you want some code to be executed when a certain event occurs, like a model view property change or a game event. So let's see how uFrame can generate boilerplate bindings for us. If we hit this plus button on some view, we can find a list of all the properties of the current view model. Now they're in the platform category, which actually means they are not used by this view. If you click one of those, you can see that it's added to the bindings to add category, which means that it's not really there, but it's going to be generated when you hit save and compile. Also, you can see preview of your little partial class. This is how it's going to look like when the binding is actually generated. Let's hit save and compile, or use the shortcut. Now you can see that it's actually in the list, and if we close this window and open it again, we can see that health changed is actually in the existing category now. Now, if we open Platform GUI view, we can see this little handy method generated for us. This is something that you're going to utilize when actually coding the game. You can rely on those values and update your view accordingly. What's cool about it is that you didn't have to write any boilerplate code to subscribe this property. Also, you don't care about what's going to happen with those bindings when your view gets destroyed, because they are all stored in the view object, and all the bindings are going to be destroyed along with your view. On the right hand side here, you can see that in our class, which belongs to this particular view and defines its own unique stuff, you can see a few things generated, like for example the overridden bind method, which actually produces the binding, and it binds the health property to the health changed method right here, which is virtual, and that's why you can override it here. Also, you got this little boolean variable generated, and this is what you can see when you add your platform GUI view to the scene and expand this bindings fold. You can see health here, and this is how you can manually disable binding even though you have this generated in your view. Now, when you know the basics of what's going on in the view classes, you can just close this file and never open it again. The only thing you need to know is how to use the editor to actually add the bindings and utilize the generated methods. But the cool thing, really cool thing, is that you still can use all that stuff which was shown in this designer file. If you will ever want to subscribe to some property which is sort of remote and doesn't belong to this particular view model, you can just use this bind property here, bind property method, which accepts so-called selector, and give it an appropriate handler. If you don't know what the selector is, it's just a lambda function or a lambda expression which returns something. You use this because you never know when your platform actually gets initialized. So you can't just pass platform.health property here, because it may give a null and your binding will be broken. Instead, you give it a hint of what kind of stuff should be invoked in order to get the health property. And this is a very powerful feature, you know. So let's make a little summary of what we currently know about views. You work with the views using partial classes, which correspond to the view name. Every single view can execute commands which are defined on the current view model. You can use helper methods for those, which are named using execute word followed by a command name. If you have an argument for the command, you will be allowed to pass it as a parameter. Also, every single view is bound to the view model, so you can utilize bindings. If you add those using the editor, you get helper methods generated for you, and you can use those to update your view every time the view model property gets changed. Views are monobehaviors, so they are added directly to the object, like this, like a simple script. Views can help you to set up initial settings, not only for the view itself, like for example disabling or enabling bindings, but they also can help you initialize the view model with some settings, if you will. Yeah, make sure this fold is actually expanded. Views can send commands to the view model and respond to changes from the view model. And that's basically everything we want from the view. So now it fits nicely into the MVVM pattern. And yeah, that's it. But views allow you to do much more. For example, they can handle collection changes as well, and also define what happens when a certain event happens with the collection. And also they allow a lot of other things that you can find useful as a developer, but for now it's basically everything you need to know. Now it's time to talk about controllers. Controllers are quite simple, but there is one thing that may confuse you if you're not familiar with such architectures as MVC and MVVM. If you worked a lot with monobehaviors, you're probably used to have a lot of properties for this object as well as methods which modify those properties. But now when we have view models separated from the logic, we don't need a lot of guys that will modify the view model. Instead, we can just have one controller which will manage the logic for each model type or view model type, one at a time. uFrame generates controllers based on your elements or view models. So in the controllers folder, you will see 3 types defined for each of the view models in your diagram. Let's open one of those. It's a bit different from the view and the view model because it's not partial, but it is derived from the enemy controller base, which is stored in the corresponding designer file. You can learn a few cool things here. For example, this property shows how you can utilize the built-in dependency injection. Every time you need to inject some sort of a controller into another controller, you can use the inject attribute, then define a controller type, for example, platform controller. Then you can change the name, and uFrame will take care about the rest. Also, you can see that we got a few useful methods generated for us. Those will be invoked every time a particular view model of the enemy view model type will send a command like hit or earth-reached. Finally, you can see where the initialize method is actually invoked. This one is this one. Every time you will need to handle a command for an enemy, you can just override the method with the same name as the command, and here you can set your enemy to be dead. This is how everything works. You get a command from the view that the enemy was hit, because view can send commands or execute commands. This is the same. When the view executes command, the hit method on the controller is invoked. And here you can define your logic rules, like setting the enemy is dead to true. At this point, binding will work on the view if it's there and if it's generated. So you can update your view and make the enemy look like he's dead. But let's take a look at platform controller base. As you can see, it also handles viewModel's commands, but in a slightly different way. It doesn't provide any information about the sender of the command. This is because uFrame goes ahead and does not produce redundant information about the viewModels which are unique or single instance. If you look at the diagram, you will see that enemy has this little star sign right here. If you right-click, you can see that it has multiple instances field checked. This means that there can be a lot of viewModels of this type, while platform is considered to be a single instance element. If we hit this, click Save and Compile, and just reopen the diagram file, or the designer file I mean, you will see that now platform commands are handled in exactly the same way as enemy commands, while Pinky Alien's game remains the single instance element. So when you have a single instance element controller, you can refer to the only existing viewModel directly using the generated property. Like here in the Pinky Alien's game controller base, you have a Pinky Alien's game. And look at how container is used to resolve Pinky Alien's game viewModel. This is something that may come in handy when you work with the views too. So just remember this thing exists, and maybe we'll utilize it later. Now let's make a little summary, I guess. Controllers hold you logical rules, and you can modify your viewModel every time you get a command. To handle the command, you can override the method which has the same name as the command. For the single instance elements, you can refer to the viewModel directly using the property which corresponds to the viewModel name. For the multiple instances element, the information about the sender is provided in the parameter. Also, you can use initialize method in your controller to set up any additional settings when the viewModel appears in the world. And finally, controller allows you to use dependency injection to make connection with other controllers. And congratulations if you made it this far. I hope now you have a basic understanding of how things are connected with each other in uFrame. And yeah, it's time for some bonus information. First, let's take a look at how we can instantiate viewModels and appropriate views. As you may remember, every viewModel has a few constructors generated. That's why we can utilize those. But you should always remember, if you use the default constructor, your commands will not get initialized because you provide no controller. To fix this, you can, for example, use a controller property and set this to some controller which is bound to work with this viewModel. At this point, this platform controller will handle all the commands which come from this viewModel. But this is something that can be considered a boilerplate code. So uFrame goes ahead, and for each controller, it generates a special create method which will produce viewModels of the corresponding type. That's why we have this create platform method right here. This one will initialize everything for you, so you don't even have to care about the rest of the stuff. Another important thing is that if you use the create method, then viewModel get passed through this initialized method, which is defined on every single controller. But if you use the constructor, and even not the default one, you won't get this happen. So pay attention to this. Now let's observe how this is happening live. So let's remove this and go to our diagram and add a special debug command to our PinkyAlliance game. Hit save and compile. Now back in the Visual Studio, we can navigate to PinkyAlliance game controller. We can find this little method here which handles the execution of the debug command. And since PinkyAlliance game element is connected to platform and also it is connected to the enemy, we got both of those controllers injected for us. That's why we can, for example, create a platform by getting the platform controller and invoking the create platform method. Without much of details, I'll explain what's happening right now. Every time you invoke platform controller.createPlatform, a view model is created using one of the constructors, then it gets passed through the initialize method of the controller which you invoke this method on. And finally, you got a ready-to-use view model. Now let's utilize this one, and since our PinkyAlliance game is a single instance element, we can grab the only existing view model directly from the controller using the property and set its player to the newly created view model. At this point we know that view model property has changed, but no one cares since on our view we do not have any bindings, and that's why we're not going to get any kind of view generated for the platform 2 unless we have a predefined one in the scene. So let's go ahead and create a binding, and indeed uFrame allows us to do this. Let me also add a score changed binding in order to show you the difference between how primitive types and view models properties are handled. Bindings are there, so let's go take a look at them. As you can see, we got those two methods generated. But what's going on inside the designer file? This is a very interesting question for discussion. Let's take a look at score changed virtual method. As you can see, it has no code inside. But the player changed is full of stuff, however. This is happening because uFrame goes ahead and predicts that we're going to produce some sort of a view for a newly created view model. So the first thing it does is it creates a new setup for us called player prefab. Now if you drop the PinkyAlliance game view, you can see that in your bindings you can set up a prefab for the player. Then every time player is changed, before actually invoking your code, it will do something. First, it will destroy the previous player if this one was set. So it's going to kill the platform that was before, and this will destroy all the bindings and stuff, you know. And then it's going to resolve our view by either using the prefab if it has something set up here, or trying to instantiate it using some sort of a generic algorithm. So every time you change your player, you're going to get a new view created based on the given view model and the prefab you set here, or based on what you have in your resource folder. We will talk about it in the next parts of the tutorial. But now you should know that you can always avoid these kind of things happening by just removing the base invocation. So now you can do whatever you want with the new view model, utilize those methods like instantiate view, but do it in your own way. And also you should not expect those properties like player to have appropriate view because it's only used here in the player changed base invocation. So if you don't invoke this, don't expect this to have any sensible value. So let's make a little summary now. The responsibility to create views belongs to either you when you design your scene and drop them directly here, or it belongs to the views which are sort of parents of what you're going to create. Like this Pinky Aliens game is a parent of the platform view model. Of course you can invent your own way to instantiate views, but that's how standard things work. If you use binding for a primitive type, or for a property of primitive type, you're going to end up with empty virtual method here and have no side effects. If you have binding for a view model property, then you're going to have a sort of standard code generated for you, which you can always override by not invoking this base method. And at this point, you can invent your own ways how you can utilize the newly created view model. For example, instantiating a view based on some dummy prefab Now if you save and wait a bit before it compiles, you can see this little dummy thing here, and you can set up a prefab which will be used every time player changes to instantiate this view. So you can be very creative with what you can do here. If you keep invocation of the base method, however, like this one, you can expect certain properties of the view, like _player, to have an appropriate value or a reference to a view which is connected with this view model. So if you use the base method, you will always have the up-to-date information. And views can be even more powerful. If you go to bindings, you can see that you also have special types of bindings which are available for you. Those refer to the collection, and they are a topic for a big discussion, so in the later parts of the tutorial I will show you how to utilize, tweak, and hack those. Another useful feature you're gonna utilize a lot is a cross-controller communication. This refers to the situations when you need to handle some logic based on the view models beyond this particular controller. Like, for example, enemy hit or enemy is dead actually means that we should increment the score counter on the Pinky Aliens game, but enemies' view models are beyond this controller. So let's see how we can make this work and make controllers communicate with each other. In this case, with this particular setup, you have three ways of doing this. Our logic relies on two things: command execution on the enemy, which is called hit, or his state, which can be true or false and is called is dead. So somehow we need a certain method executed here every time is dead of the enemy is changed to true or a command hit is executed. First, let's create a method called enemy died. Make this public, and since Pinky Aliens game is a single instance, we can use the property and increment the score counter. Now, if we go to enemy controller, we already got a few things here, so let's go ahead and use the wired or injected Pinky Aliens game controller to directly invoke the enemy died method. Now, every time the command is executed, it's going to do its own logic and then update the Pinky Aliens game controller with the event that enemy has actually died. However, this makes things a little bit too much coupled, since our enemy can work with the other parts of the application and may not rely on the Pinky Alliance game at all. So another thing you can utilize is the fact that you create enemies using this Pinky Alliance game controller. Let's create an enemy instead of the platform. Also see how you can add the enemy to the collection, but it's not required right now, but for the sake of the example. And let's actually rename this to enemy. Now, controller provides a few methods for you. Subscribe to command and subscribe to property. And this is exactly what we can do when we want to, handle the logic of the command called hit or the isDead. If we want to use the command, we can just do subscribe to command, get our new enemy, hit command, and finally define a handler. Like this. So now every time enemy gets a command hit executed, it will also invoke this enemy died method. But I'm not sure about the order of the execution, and that's a good question because I haven't found this in the documentation. So the question is, what gets executed first, enemy died or this hit handler right here? And the last thing you can use is the isDead property, because controller allows you to subscribe to property, but you have to enter the source of the property. It means the view model, like the enemy one. Then you enter the property itself and the powered up property, I mean. Finally, you add a handler. But this handler has some additional parameters. Let's see what gets generated for us. You see, this argument 1 is actually a view model, or the enemy, if you will. The second argument is the current state of the property. And this one can also be invoked when the isDead is set to true, so we have to explicitly check this. If the enemy is not dead anymore, then we increment the score. And yeah, seems like I have to get some more coffee, because, we usually get points if we kill the enemy and not make him alive, or revive him. Another thing to mention here is all the bindings that are actually created are stored in the view model. So we can see the source is actually our enemy right now. And that's why you have this unbind method on the view model. So this one will automatically unbind all the bindings from all of the controllers. And when your view model actually dies, or passes away, or whatever verb you can use, all the bindings from all the controllers get destroyed as well, and you don't even have to care about it. And you won't get any, null pointer exceptions or anything else like this. Finally, last one thing that can come in handy when you feel like your designer files got broken, and even though uFrame has a super active development and very nice support, and bug fixes come every week or so, it still can mess up your designer files a bit. So for the sake of the example, I have broken my designer file here. To fix this, I can just remove all the designer files. and save and compile the diagram again. And you see I got all those generated and the error is gone. So yeah, don't put any code into the designer files because they are regenerated a lot and it will disappear at some point. Well, if you're still watching me guys, then I admire you. That was a long way, but I hope now you understand a lot and know a lot to actually start coding and diagnose your issues. Because as you can see, everything is structured in a very consistent and logical manner, and every time you have a problem you can refer to the source code and see what's going on. I'm glad to announce that that was the last theoretical part, so no more 40 minutes of code explanation. We're finally going to get our hands dirty and make some games. So see you in the next part.